Good morning, students. Okay, yesterday we have started the elective one, 5th semester. It is a three-dimensional geometry, and I have given all the introduction of the units, and we have seen first and second blocks, and even third and fourth. Okay, so fourth only lightly we have seen. So if we have time, I'll tell about the cone and cylinder. Okay, so what is the equation of the cone? What is the equation of the cylinder? Circular cone and circular cylinder. We have last fourth block, and the third block is about the sphere. It is there. So in the sphere, if the equation of the sphere, if we know, we can find the center and radius. Okay, and first two blocks are the introduction of whatever the three-dimensional geometry important points are there for solving the problems of other units. Okay, so first unit almost you have the introduction of the coordinate system, which we have which you have studied in your 9th and 10th classes. Even in intermediate you have studied the two-dimensional geometry you have studied. So in the line equation is there, plane equation is there, and also finding the point of intersection, coplanarity. So different topics are there. Okay, so today we'll start about the first unit. It is the Cartesian coordinates is there. So in that we have the direction ratios and direction cosines. Okay, so the main important in unit 1 is to know about what are the direction ratios and what are the direction cosines. So if you know the concept of this one and how to find when direction ratios are given, to find the direction cosines. Okay, so for that, even in the introduction I have told the formulas are, that is L comma M comma N, it is represented as a direction cosines. They make with the angle cos theta. Okay, that's why whatever the directions angles you are getting with respect of alpha, beta, gamma, we are doing with the help of the cosine angle. So that's why they are called as the direction cosines. Okay, so even if it is a positive direction of x, y, z, then we'll represent them as positive L comma M comma N. So when they go to the negative direction, that is in the negative whatever the quadrants are there, so they will be in the form of, that is minus x, minus y, minus z. Okay, and the cosines will be minus L, minus M, and also minus N. So with the help of the direction cosines, we will find the direction ratios, and the direction ratios, they are proportional to the direction ratios are proportional to the direction cosines. So we'll take the three numbers. Those numbers are a comma b comma c, and they are the proportional to direction cosines. So that is L comma M comma 1. We get the relation between them, that is L equals to plus or minus a by under root of a square plus b square plus c square. So M equals to b by under root of, same you will get whatever in the denominator is there, a square plus b square plus c square, and also n equals to c by under root of a square plus b square plus c square. So this is about the direction ratios and direction cosines. So if you know, if you want to know the in depth, you have the proofs are there, theorems are there in your textbook. So almost to know the concept of the direction ratios and cosines, just you can go through them. Okay, so we'll see the problems which are present in the unit 1. Yesterday even I have told that to find any distance between any 2 points, we have the formula is distance between the 2 points x1, y1, z1, x2, y2, z2. So if we represent it as any P and Q, this is a P and this is Q, we'll write the distance as PQ equals to under root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so similarly for our problem, if it is asked that find the distance between the points so the points given are minus 4. So in the question it is mentioned that it is the point P. So minus 4, minus 3, minus 6, and Q is 2, 5, 1. Okay, so we have to find the distance between the 2 points. So here whatever the theory part is there, to solve the problem, you try to collect from your textbook. Okay, just I am telling the solution here. So the distance of here PQ is equals to, and first you write here what is, this is x1, y1. So it will be easy for solving any problem here. So it is x1, y1, z1, and it is x2, y2, z2. Okay. So when you substitute those values in the formula, our x2 is 2. So already minus is there. So minus of minus is plus 4 whole square plus 5. And even for this also you have the negative. So it is plus 3 whole square plus 1 plus 6 whole square. Okay. So when you simplify this, it is 2 plus 4 is 6. 6 square means it is 36. Next 5 plus 3 is 8. 8 square is, you have 64. Plus here 6 plus 1 is 7. 7 square is 49. Okay, when you add that, you will get it as 149 you are getting. Okay. So you can keep like that. It is a distance between the 2 points P and Q. Okay. So next, even I have told what is the concept of the collinear. Okay. So if the 3 points lie on the same line, then we call the 3 points as they are collinear to each other. So depending on this also, 1 5 marks problem you will get in the examination. That is the first question you may have on collinearity or finding the distance between the points. Okay. So you have the definition in your textbook. It is a collinear means if 3 or more points lie on the same line, they are said to be collinear. Okay. So if you see the problem, it will be show that so collinear means first you have to find the distance between the whatever the given points are there. With the help of that, you find the show that the points 2 comma minus 4 comma 3 and minus 4 comma 5 comma 6, 4 comma minus 7 comma 2 are collinear. So whatever the procedure we are finding for the collinear, even you can apply the same procedure for finding to show that the given points are whether they are right angled isosceles triangle, or to show that whether it is forming a square or equilateral triangle or a parallelogram, whatever they are given the points. So same thing is you have to take the first you put the whatever the points are given, you name them as PQR or ABC. Then you find the distance between the two points, and then you see what is the relation between in them. Okay. So here we can represent here first point as if it is A, it is 2 minus 4 minus 3, and second one B, it is minus 4 5 6, and D C is equals to 4 minus 7 2. Okay. First we will find the distance between AB. So AB means under root of, and even you put this as, if you want you can put them as x1 y1 z1 and x2 y2 z2. Okay. Minus 4 minus 2 whole square plus 5 plus 4 whole square plus 6 minus 3 whole square. Okay. So this is minus 6. Minus 6 whole square means you will get 36. Plus 5 plus 4 is 9. 9 square means you will get 81. And 6 minus 3 is 3. 3 square is 9. Okay. So you will get 90. 90 means 126. You will get this one root. So root 126. If you find the root of this one, you will not get the perfect square, but you can write it as 3 root 14. Okay. Okay. So this is AB. Now we'll find BC. So the distance between the points BC is 4 minus of minus is there. That means 4 minus into minus is plus 4 plus 4 whole square. Next minus 7 minus 5. Next 2 minus 6. So this is 4 plus 4 is 8. 8 square means you will get 64. And this is minus 12. Minus 12 means you will get square no. So 144. Next to 2 minus 6 is minus 4. Minus 4 whole square is plus 16. So this you will get it as root of 224. So you add them and check that one. And if you write the whatever the root is there, if you convert that, you will get it as 4 root 14. Okay. So this is about BC. Now we can find AC. So AC is equals to under root of 4. So here AB means actually we'll write it as OB minus OA. Okay, if you have any confusion, you can take this as OA, OB and OC. So AB is equals to this, whatever the second term is there, that minus the first one. So OB minus OA, here also OC minus OB, here also it is OC minus OA. Okay, so AC means here this minus this one, 4 minus 2 whole square plus minus 7. Here already minus 4 is there, minus of minus it will become plus 4. Next to 2 minus 3. So here 4 minus 2 means 2 you will get 2 square is 4. Next minus 7 plus 4 means minus 3. Minus 3 whole square is 9. Next 2 minus 3 is minus 1. Minus 1 whole square means you will get as 1. So here you will get it as root 14. Okay, 2 into 7 we can write root 14. But we can't split as like this. So you will leave with that one. So it is only root 14. Now you have to show that the given points are collinear. Collinearity means here, if you find the distance between the, here whatever the points are there. So distance between any two points, when you do either that is AB plus BC, when you add them, you have to get the third one. Okay. So that is called if any of two lengths, it is equals to the third length, then we call it as a 3 points, they lie on the same plane. So they are collinear to each other. So here by seeing the AB, BC and AC, so which if you add both of them, you'll get the third one. So here if you add AB and AC, AB is 3 root 14 and AC is root 14. If you add them, you'll get this for BC, no? 4 root 14 you will get. So then we can show that the given lines are collinear to each other. In some cases, in the given problem, you may not get like this relation. When you are unable to get that one, then you write that they are not collinear to each other. Okay. So here AB plus AC, therefore AB plus AC. So AB plus AC is 3 root 14 plus root 14. So it is equals to 4 root 14 and it is equals to BC. Okay. You are unable to see. Yeah? Okay, here AB plus AC. AB plus AC is 3 root 14 plus root 14. So it is equals to 4 root 14 and it is BC. Okay. Therefore, A comma B comma C are collinear. So like this, you have to solve the problem for any, even if they ask for square or also equilateral triangle or anything. If it is a triangle, you also you have to find the same distances. Isosceles triangle means two sides will be same, no? So any of from these two, you will get the same values. Okay. So then we can tell that it is an isosceles triangle. And if he's asking the right angle isosceles triangle, then you have to, with the help of the Pythagoras theorem, you have to show that whatever the any here AB or BC or AC of any two squares, that is AB square plus BC square equals to AC square whole square. Okay. So of that, if they are equal, then we can tell that it is an isosceles right angled triangle. So that question you have in your check your progress, you have the solution is given at the back of your unit. So try to practice all these problems. This is the compulsory 5 marks question you will get. So next we have the concept of from this only Yesterday I have told the for finding any point, whether it is internally or externally, if the line is divided into in the ratio, that is lambda is to 1 or m is to n, we have seen. So with the help of that, we can find what is the midpoint between the 2 points also. So that formula, even this problem is also important. So 5 marks problem you will get on this. So the formula will be like this: coordinates of points which divides Are you able to see? Coordinates of the point which divides.
Ma'am, we can't see, ma'am.
The line joining not seen.
Ma'am, board is not visible, ma'am.
Yes, wait. Now that line you are pairing, no?
Yes,
So
ma'am.
coordinate only upside the whatever the unit name is there, you are unable to get that one. Which is just I have written the unit name. So here the formula for coordinates of point which divides a line joining the points x1, y1 and x2, y2 in the ratio m is to n. Okay. So that will be m. For 2 you will have for internally and also for externally you have. So whenever it is asked in the question to find the coordinates of the point which divides a line joining the points, both these in m is to n ratio. In the question it is not mentioned internally or externally. Then you can use this one. So specifically if he is mentioning externally means just you will have m is to minus n. Okay. So wherever n will be there, you put there it as a minus. Okay. So m into x2 plus n into x1 by m plus n comma m into y2 plus n into y1 by m plus n comma m into z2 plus n into z1 by m plus n. Okay, like this you will have. So if it is minus n means what will happen here? Minus sign in the denominator also minus sign, and it will be asked for externally. So that you have the formulas on 13th page number you have. So whenever the ratio is given in the question and 2 points are given, so he's asking the coordinates of the points which divides the line joining these 2 points. So the ratio if it is given and 2 points are mentioned, then you directly substitute in the given formula. Okay. So we'll see one example for this one. If the points are, so you see the question, just I am writing here the points. The point is P minus 2 comma minus 4 comma 3 and Q or minus 4, 5 comma 6. So they divide in ratio 2 is to 1. Okay. So if 2 points are given in ratio 2 is to 1. So you will have the question, find the coordinates . Find the coordinates of the point which divides the line joining the points. Okay, the points are here these. So the question will be asked, find the coordinates of the point which divides the line joining the points P and Q in the ratio 2:1. So here m value is 2 and n value is 1, and whatever the points are given, they are x1, y1, z1, x2, y2, z2. Okay, now substitute here. Here it is not mentioned whether it is internally or externally. So whenever it is not mentioned, directly you take it as a only internally. Okay, so whatever the formula it is there, you write in that. So that here you will get it as m into, what is m value? 2. 2 into x2 is -4 plus n into n value is 1 and x1 is 2 by 2 plus 1, m plus n. Okay, so comma m is 2, 2 into y2. y2 is 5 plus 1 into y1 is -4 by 2 plus 1. Okay, so next 2 into z2, no, z2 is this one. So 2 into -6 plus 1 into 3 by 2 plus 1. Okay, so it is -8 plus 2 by 3, and this is 2 5s are 10, 10 minus 4 by 3. Next this is -12 plus 3 by 3. So here it is -6. -6 by 3 means -2. 10 minus 4 is 6. 6 by 3 means 2 you will get. And this is -9. -9 by 3 means -3 you will get. Here the coordinate -2, -2, -3 divides the line joining the points. Whatever the line you are getting PQ as a line, so it is dividing the point. The point is here -2, -2, -3 in the ratio 2:1. Okay, so if any points are there in theoretically writing, so try to follow from the example problem. Okay, so whenever like this point is asked, so if it is here the m:n ratio is in the form of 1:1. So if the ratio is 1:1, then you will get the midpoint of the 2 points. Okay, so here m comma n 1 comma 1 means what you will get? M 1 value, 1 value. So x2 plus x1 by 2. I hope so all of you know the midpoint. If x1, y1, z1 and x2, y2 and z2 are the 2 points, then directly you know the formula, that is the midpoint of these 2 points is x1 plus
x1 plus x2 by 2, y1 plus y2 by 2,
y1 plus y2 by 2,
plus z2 by 2.
z1 plus z2 by 2. We know that. But how we got this one means whenever you put whatever the here ratio is there, in the ratio 1:1, that is m value is 1 and n value is 1, then you will get the midpoint of the 2 points. Okay, so even you may get as a 1 mark question, that is 2 points will be given, he will ask to find the midpoint of that one. Okay, so directly you can add both of those 2 points and divide by 2. Okay, so you remember that one. So 5 marks, you have the series, no? So one you may get the collinear and another one is this one, finding the coordinate. So almost in first unit you will have all the 5 marks questions only. So try to solve all the example and also check your progress problems are there in your test book. So try to practice them. Okay, 14 page number you have. Next, already in the introduction I have told what are the direction cosines and what are the direction ratios. Okay, so on that we'll solve one problem, and you remember that here, that is L comma M comma N are direction cosines. Okay, and here when we go to the direction ratios, any 3 numbers A comma B comma C are 3 numbers. Okay, so they are proportional to direction cosines. A comma B comma C are 3 numbers which are proportional to direction cosines. Okay, so that relation you will get it as so here we are telling that whatever this proportionality is there, we are assuming one number, that is k. If you say, so then you will get L equals to AK and M equals to bk and n equals to ck. So we have one relation, no? So you remember this relation, this proof is also there in your textbook. L square plus m square plus n square. This is a very important one. L square plus m square plus n square equals to 1. Okay, if you substitute in this, you will get L square plus m square plus n square. That is ak whole square plus bk whole square plus ck whole square. So if you will take out a square common, you will get it as a square plus b square plus c square. And even you know this value is 1. So 1 is equals to k square of a square plus b square plus c square. So you will get k square is equals to plus or minus 1 by under root k value. You will get that one. Okay, a square plus b square plus c square. If it is k is plus or minus 1 by under root of a square plus b square plus c square. Okay, whenever you substitute this k value here, what will happen? L is equals to a by, that is for all you put it as plus or minus, it is a square plus b square plus c square. And m is equals to plus or minus b by under root of a square plus b square plus c square. Okay, and n is equals to plus or minus c by under root of a square plus b square plus c square. So this is the relation between these, whatever a value is there, a b c, these are the direction ratios. Okay, and l comma m comma n, these are the direction cosines. So the relation between them, you have to remember this one. So this procedure almost you use in block 1 and even block 2 also problems. So you will have there the concept of direction ratios and direction cosines. Okay, so one 5 marks problem will be given. So here the numbers a b c will be given in the question. You have to find what are the l comma m comma n values. Okay, see, like question will be like this: if 3 comma minus 4 comma 12 are direction ratios of a line, then find direction cosines. Okay, so here you see in the solution what are ABC values. So here we have A is equals to 3 and B equals to minus 4 and C is equals to 12. And we know the formulas here. What are the formulas for the direction cosines? So L is equals to A by, no, so A means here 3 by under root of, that is 3 whole square plus minus 4 whole square plus 12 whole square. So it is equals to plus or minus 3 by under root of 3 square is 9, 16 plus it is 144. So 25, no, you will get 169. 169 means it is 13.
13.
So it is, so at the side, you will do the rough side, no? So there you can find this denominator value and directly you can put for L, M and N. Okay. So what will be M?
Minus 4 by 13.
So minus 4 by 13. Next N will be
12 by 13.
12 by 13. Okay. So like this we have to find if any point of direction ratios are given, then we can find with the help of the formula here L comma M comma N, those are the direction cosines. Okay. So now you write the direction cosines are, first what is L? L is 3 by 13 minus 4 by 13, 12 by 13. You write in the coordinate form. Okay.
Ma'am,
Yes, ma'am.
we got minus 4 by 13 as M, no ma'am. Then
What, ma'am? Once again repeat.
We got M is equal to minus 4 by 13, no ma'am.
Yes.
So when we convert it into angle, we should take 180 minus that value, ma'am.
190 na.
180, ma'am. 180. If we want to convert it into angle.
Okay, here no need of converting into angle. Just
Yes,
what are the element values, we have to find that them only.
Okay, ma'am.
So we are not going into cos, that is cos alpha, cos beta, cos gamma angles.
Yes, ma'am.
Okay.
Yes, ma'am.
So almost they will be asked in the separate way. That is, they will ask in the angles 45 degrees or 60 degrees. So that problems also you have. See on page number 18, you have a line makes angle 45 degrees and 60
Yes,
degrees with the positive axis of x and y. Then find the angle that it makes with the positive axis of z. So there we are taking L value as cos alpha. So angle will be given in the question. So m equals to, we have cos beta and n equals to cos gamma. So here he has given the two angles, that is cos alpha and cos beta values. He has given two. This is for x, no, this is for x and this is for y and this is for z. So two angles are given for x and y. He is asking to find the third one, that is for z. So when in the question he is mentioning angles, we have to
then
use
only we
this
should find.
Okay. So with
Yes,
the help of that, when you find both of them, you can find the third one. Okay.
Yes,
So that the example problem you have in page number 18 you have. So in that
Yes,
he is using the relation L square plus M square plus N square
n
equals to
square is
1.
equal to 1.
So from that you will get the third angle.
Yes.
Okay.
Yes, ma'am.
So next we have the concept of the projection of a line will be there whenever 2 points are there, x1 same, x1, y1, z1 and x2, y2, z2. So the projection of line between these 2 points, we'll get it as x2 minus x1, x2 minus x1 by L equals to y2 minus y1 by M equals to z2 minus z1 by n. So here we'll mention this, whatever LMN are there, these are the direction cosines. So before that, when we solve this as a theorem, it is the distance of PQ we'll have, okay. So that you have the concept on page number 23, we have projection of a broken line consisting of continuous segments is there. Actually, we need only the formula is there, that is on page number 25 you have PQ equals to x2 minus x1. That is here shown in the vectors. Here I, J, K are there. No, it represents they are in the with the help of the vectors. It is there. So here last whatever point is there. Therefore the projection of PQ on the given line is equals to L into x2 minus x1 plus M into y2 minus y1 plus N into z2 minus z1. This is of finding the SD. I have told no in second block you have the coplanarity is there and also point of intersection is there, and for finding the shortest distance between the two lines there we'll use the concept of this projection of the line. Okay, this formula we'll use there. And even whenever the line equation is there, I have told unsymmetrical form and symmetrical form. No, in that if you observe that one, the line equation will be like this: x2 minus x1 by L, y2 minus y1 by M equals to z2 minus z1 by M. So that concept you got from the first unit. What is the projection of the line between 2 points? Okay. So from this we'll get the formula for finding the equation of the straight line. Okay. So next we have the angle between the two lines here. So page number 26, if you'll see. So angle between two lines having direction cosines. So one problem or formula you may get in objective type, or problem will be also asked. So the formulas almost they will be same for when two direction cosines are given. So here direction cosines means we'll represent them as L1, M1, N1, and next second one is L2, M2, N2. And if they ask the direction ratios means it will be A1, B1, C1, A2, B2, C2. Okay. So you have the formula for angle between two direction cosines. So these are all here objective type questions. Okay. The angle between two lines having direction cosines L1, M1, N1 and L2, M2, N2. Okay. So the proof is given in your textbook. So no need of the proof. Just whatever the formula is there, it is enough for us. That is cos theta is equals to L1 into L2 plus M1 into M2 plus N1 into N2. Okay. So this is the angle between the two lines when they are having the direction cosines of these 2 points. Okay. So when you got this value, you can write it as theta equals to cos inverse of, we need angle, no theta here. So cos inverse of L1, L2 plus M1, M2 plus N1 into N2. Okay. So this is the formula when direction cosines are given. Okay. So this, whatever the formula is there, this one only same when cos theta is converted into sin theta, you have the formula, and when you're converting cos theta and sin theta into tan theta. So for some problems, I have told in unit 2, you have bisectors is there. So for finding the angle of bisectors for the planes, 2 planes, we'll use cos theta. If cos theta value, by that you may not unable to assume what is the theta value, whether it is greater than 1 or less than 1, you can convert that cos theta into tan theta. So directly you can convert that one, or else with the help of the Pythagoras theorem we have, no, through that also you can do. So here formulas for sin theta and tan theta also given in your textbook. Okay. So next you will have for the direction ratios. Okay. If theta is the angle between two lines whose direction ratios. Okay. So direction ratios means it will be A1, B1, C1 and A2, B2, C2. Okay. So for these direction ratios, we'll use L1, M1, N1 as direction cosine of this one, and L2, M2, N2 as the direction cosine of this direction ratio. So through that, you have the proof of that one. Just I am writing here what is the formula of that. So you will get it as cos theta equals to plus or minus A1 into A2 plus B1 into B2 plus C1 into C2 by under root of A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. Okay. This is the formula when direction ratios are given. That is A1, B1, C1 and A2, B2, C2. So whatever the numerator is there, that you will get from here cos theta we have, no, L into L1, L1 into L2 plus M1 into M2 plus N1 into N2. So these direction ratios we are considering with respect of direction cosines. So from that conversion, at last you will get cos theta is equals to plus or minus this formula. So here also you have for sin theta formula is there, and even for tan theta also you have formula. So almost for solving the problems we will use this one only, cos theta equals to plus or minus this one. Okay. So you, and here the conditions are important. So condition of, this is the objective type question you will get, or else for solving the problem also they will give. Condition of perpendicularity is there. So condition of perpendicularity. So it is, we'll take here the theta value as pi by 2. So what is cos pi by 2? Cos 90 is 0, no? So cos 90 is 0 means here when you put the theta as pi by 2, this 0 is equals to this one. So whatever the denominator is there, when you do the cross multiplication, it will become 0. So the left one is only A1, A2, B1, B2 plus C1, C2 equals to 0. Okay. This is the condition for the perpendicularity when two direction ratios are given. Okay. So when you go to the here, you will get it as, it is also cos pi by 2. Cos pi by 2 means the value is 0. So L1 into L2 plus M1 into M2 plus N1 into N2 is equals to 0. That is the condition of perpendicularity. Whenever 2 points are given, if he is asking that whether they are perpendicular to each other, then with the help of this formula, you can find that one. Okay. So here next one is L1 L2 plus M1 M2 plus N1 N2 equals to 0. So this is the even 1 mark bit. What is the condition of perpendicularity when two direction ratios are given? Okay. So next one is condition of parallelism. Okay. So able to see, condition of parallelism means you will get theta value as 0. Okay. So whenever theta value is 0, so you will get here sine theta value. For sine, we will consider this one, sine theta equals to, so sine 0 is 0, no? So this value is 0. Okay. So when you put that sine value in your formula given for the sine theta, you will get it as the relation as, so I am writing here, so that is A1 by so this means this value should be equal to this one, this value should be equal to this one. Then whatever the points are given, they are, this is the condition of parallelism. Okay. Next, for this one, L1 by L2 plus M1 by N2 equals to N1 by N2. Okay. So these are the conditions of perpendicularity and also for parallelism. So these and these, even for solving the problems also we'll use these conditions. Okay. So we'll see one problem on angle between the two lines when the direction ratios are given. Okay, find the angle between lines. Find the angle between two lines having direction ratios 1, 1, 2 and root 3, minus root 3, 0. Okay, here the direction ratios are given as this. So direction ratios means this is A1, B1, C1 and here A2, B2, C2. A2, B2 and this is C2. So we know that you write the sentence if theta is the angle between two lines whose direction ratios are. So we'll get it as cos theta is equals to plus or minus. So A1 into A2. So that is 1 into root 3. Next plus B1 into B2. So B1 is 1 and B2 is minus root 3 plus C1. C1 is 2 and C2 is 0. Okay, by under root of so this whatever the A1, B1, C1 are there, their square we have to find.
1 square
that is 1 square plus,
plus
1 square plus
2 square
2 square
into
next
root 3 whole
square
square
plus minus root 3 square plus
0 square.
0. So 1 into root 3 is root 3 and this is minus root 3
minus
and
root
this is
3
already
plus 2.
0. And in the denominator you will get 2 2 square is 4. These two are 1. It is root 6.
Root 6.
And here it is root and square will get cancelled 3. And this is
Six.
also
Root
3.
6.
0. So you will get it as
Root 6.
root 6. So but in the numerator it is becoming 0, no?
0.
So it is plus or minus 0 by root
0.
6 into root 6 means 6.
6.
So the value is here 0. So we got cos theta value equals to 0 implies theta is equals to cos inverse of 0 here. So 0 you can write it as we need to find the theta value. So whether it is a 30 degrees or 60 degrees or 45 degrees or 90. So that what you have to find the angle of that one. So here for what value of cos you will get 0?
90.
90 degrees. So it is cos inverse of cos of pi by 2. So here for instead of 0 we are mentioning it as cos of pi by 2.
Cos inverse
So cos and cos inverse both will get cancelled. It is
pi by 2.
pi by 2. So here the angle between the two lines having these two direction ratios is 90 degrees. Okay. So here you can write theta equals to pi by 2. Okay. So this is also the 5 marks problem. In your textbook page number 28 you have. So here instead of 2 points he has given the 4 points are given. So 4 points means already has mentioned that is between any 2 points. If you take the 4 points as P, Q, R, S, first find the distance between any 2 points. Then you will get if PQ, and if you find the distance between the 2 points, you will get RS. Then after getting those, you will get only single points. No, that means PQ you will get 1 point, and if it is a PQRS, no, so RS you will get 1 point. So if these two are the direction ratios now, so with the help of the same formula you find that one. Okay, so the question may be asked like this directly with the help of the direction ratios, or they may ask with the help of the 4 points they have given. So you convert them into direction ratios and then you substitute in the formula, you will get the answer. Okay. So actually the question is if P, Q, R, S are the points, find the angle between the lines he has asked. Okay. So whenever it is the lines is given, let P, Q, R, S be the given points, the direction ratios of the line joining the points P and Q. So here P, Q, R, S. So 4 points are given. So with the help of this formula, it is there now x2 minus x1. We have y2 minus y1, z2 minus z1. Projection is there, no? So with the help of that P and Q, you find this point. So x2 minus x1 means these 2 points, x2 minus x1, and after that y2 minus y1, you will get the direction ratios of PQ. Next, if you will find these two, you will get the direction ratios of RS. Then you find the angle between PQ and RS. You if direct the same one, if you substitute in this formula, you will get the answer. Okay. So the problems may be asked like this or like this directly. They'll give the direction ratios. See page number 30. You have one. Actually, it is a theorem, but here it is given as like a problem. It is given. A line makes angles alpha, beta, gamma, delta with the diagonals of a cube. Prove that cos square alpha plus cos square beta plus cos square gamma plus cos square delta equals to 4 by 3. Okay, this proof you will have. So this is, if you get any 10 marks question here, you will get here the 10 marks question of this one. So the proof is here, first you have to draw the cube and you have to, for each and every end point, edges of the cube, you put them, whatever the points are given. So with the help of the projection is there no this one x2 minus x1, y2 minus y1, z2 minus z1. So there you substitute the values. So 6 points you will get. And here we have seen the relation no L square plus M square plus N square. If you substitute there all the values, then you will get the relation that is it has 4 by 3 you will get. Okay. So the proof of that whatever the problem is there, that also is asked in the question sometimes. So even in this unit, you have the chance of getting the foot of the perpendicular is there. See page number 29, you have find the coordinates of the foot of the perpendicular from A on the line joining B and C. So in this we are using the that is the coordinates of the points. Line joining ratio is there now. M is to N ratio, that is also mentioned in this. So if we'll go to the theorem. So here OA equals to OB equals to OC equals to A. So first you see the coordinates of this one. So diagram you have in your textbook. So it is 0, 0, 0, and A is A, 0, 0, and B is 0, A, 0, and C is 0, 0, A. After that we have P, A, A dash is 0, A, and B dash is A, 0, A, and C dash is A, 0. And the diagram will be okay, like this cube. Further we are finding. So here it is 0, 0, origin it is there, 0, 0, 0. Next we have this is okay. So these are the coordinates of the each and every whatever the point we have here. So 1, 2, 3, 4, 5, 6. So here we'll draw the here 3 diagonals will be there. So one relation is there, OA equals to OB and OC. So OA, this is the origin. Now we can represent as this one, that is OA, and this is OB, and this is OC. So you will get the value as A. So that means that only we are getting the coordinates as A as in place of X. Okay, in place of X we are getting here A value and other YZ values are 0. That means here it is 0, 0, 0. And this is X value is you get A, 0, 0. So when we go to OB, so 0, 0, 0 is the origin and B value is in place of Y. Okay, you will get the A value. So here in textbook it is given X, Y, Z. Okay, you take like this. And OC is this one. Okay, so 0, 0, 0, 0, 0, 0, A. So when you will take the other one, that is A dash of this one, A dash of this one, you will get in place of A, that is X value you will get as 0 and YZ values as A and A. So similarly B dash means here we have B and here it is B dash. So B dash is A comma in place of Y. Okay, in place of Y you will get 0 and A and C values you will get, that means X, Z values are A and A. So this is if you draw the diagonals. So you will get one like this. And this is A and A dash 1. Then you will get C and C dash. Okay. So these are, with the help of these points only, we will find the direction ratios and direction cosines. Okay. So in the solution, we have seen that let O a corner of cube as origin, and the three edges are there. The edges are OA, OB, comma OC are three edges. Okay, and for that edges we have the value, it is equals to A, and the coordinates of all the points. So point O, point A, this is the origin, A, B, C, and P is the point here. So we are getting for the T A comma A comma A. So A dash, B dash, and C dash are the points you have on these edges. And here the four diagonals are. So what are the four diagonals? O, OP, A dash, B, B dash, and C, C dash. So this is one OP. Next we have A and A dash. Next B and B dash, C and C dash. Okay. If you draw means it will become all. So you may not understand that one. So this is one, and this is B to B dash. Next C to C dash. So four diagonals will be there. So the diagonals will be OP. So O and P. So when you will take the diagonals OP and A dash, what you will get? A minus 0, A minus 0. That means you are finding the coordinates, the distance between them. So you will get here this as A comma A comma A, and A dash. So what you will get? A dash is 0. So 0 minus A. Next you will get A minus 0. Next you will get A minus 0. So this coordinates you will find with the help of the direction ratios, that is A, 0 minus A under root of A square plus A square plus A square. So you will get it as, that is A by 3 A square root of. Next you will get A by root of 3 A square. So next A by root of 3 A square. So 3 A's, no? A square plus A square plus A square means 3 A square. We have the formula now for direction ratios. A plus or minus under A by under root of A square plus B square C square. So you will get here minus A. This is A. If you will see the coordinates, it is minus A. A minus 0 is A. Next A. When you do the square of this one, you will get the same one. So A square plus A square plus A square. So it is 3A square. So if you put the root, you will get it as 3 root or A root 3. So A square means square will get cancelled. You will get root 3A. So what will be there if you substitute here? A by A into root 3. This is first one is minus. Next A by A root 3. Next A by A root 3. See, these both will get cancelled. So we'll get the point as minus 1 by root 3. 1 by root 3, 1 by root 3. Okay, for OP. So similarly, you will get for AA dash and BB dash and CC dash. So you can remember that one for OP, all positive, you will get 1 by root 3, 1 by root 3, 1 by root 3. AA dash, you will get, that is X value as negative, 1 by root 3, 1 by root 3, 1 by root 3. B dash, you will get it as 1 by root 3, and it is minus 1 by root 3, 1 by root 3. Okay. Next you will get the C value as, that is C dash is equals to 1 by root 3, 1 by root 3 minus 1 by root 3. Easily you can remember this one. So A means you will get A minus 0 means A, and next A minus 0 is A. Under root of, how you are getting 3A square. 3A square means A root of 3. So that's why you will get OP values as all positive. Next A dash. A dash means you will get one negative one. 0 minus A you are getting. So it is negative. So here negative. For next BB dash you will get in the middle term as a negative one. CC dash you will get the last term as negative term. Okay. So if we substitute these all values in the formula, that is cos square alpha, it is there, no? So cos square alpha and cos square beta, cos square gamma. So when you convert them into LMN, you will get the cos alpha value as OP A dash and BB dash and CC dash. When you multiply with them, that is L comma M comma N. Page number 31, you have seen, let L comma M comma N be the direction cosines of the given line, which makes angles alpha, beta, gamma, delta with OP, A dash, BB dash and CC dash respectively. Then we'll get cos alpha. That means here whatever the L, M and direction cosines are there, you are multiplying them with this one. So what you'll get, L by root 3 plus M by root 3 plus N by root 3. We can write it as L plus M plus N by root 3. Similarly, cos beta for this one, you will get it as minus L plus M plus N by root 3. So cos gamma equals to L minus M plus N by root 3. Next we have cos delta. It is equals to L plus M minus N by root 3. Okay. So then we have to show in the theorem, it is that cos square alpha plus cos square beta plus cos square gamma plus cos square delta. So now you do the square of this one and add them. So square of this one means you will get L square plus M square plus N square whole square. Okay. So all four you have to do. This one numerator. So you will get all minus L plus M plus N whole square plus L minus M plus N whole square. So I able to see here. Next plus L plus M minus N whole square divided by root 3 is there, no? So here one you are doing square means here 3, 3, 3, 3. Okay. So you will get it as, if you take common, you will get it as 3. So here when you expand this one, they are in the form of A plus B plus C whole square. Okay. So you will get A square plus B square plus C square plus you will get AB, BC, CA. Okay. So here one negative value, here also negative values, here also negative values. So all the values almost they will get cancelled. Only you will be left with L square plus M square plus N square in the 4. So you will get it as 4 into, you expand that one and if you will check M square plus N square by 3 you will get. So this value you know from the starting one, that is it is equals to L square plus M square plus N square is 1. So if you substitute here that one, you will get 4 by 3. Okay. So this is the solution of the whatever the given theorem is there. So like this, first you find what are the points of this one and you find the direction ratios of that one with the help of doing the subtraction of OP A dash. First thing is, if you will get these values, then you can take L comma M comma N as the direction cosines, and with the help of the formula we have A into A1 plus B1 B into B1 plus C into C1. Okay. So like that here you are multiplying with L comma M comma N with this one. So whenever it is this one, for OP, if the angle is alpha, then cos alpha equals to L into this one, M into this one and N into this one. So when you add that, you will get as this one. So cos alpha, cos beta, cos gamma and cos delta. So we need this relation. In the question is asking to find the relation of this one. So when you do the square of them, if you expand this one in the form of A plus B plus C whole square. So somewhere all AB terms, that is LM or MN or NL terms, almost they will get cancelled. All they will get cancelled. On the remaining will be only L square plus M square plus N square. In this one it is there. In this one, in this one, in this. So 4 L square plus M square plus N square are there. When you add them, you will get 4 of this one divided by 3. Here When you cancel out the root, 3, 3, 3, 3. Okay, you are taking the LCM common here. So by 3 you will get. And we know the relation. It is L square plus M square equals to 1. You are using that relation here. So you are getting the answer as 4 by 3. Okay. So this is just you draw the diagram and you mention what are the coordinates of all the whatever the points are there. Then you find how I have told now how to find OP, A dash and BB dash and CC dash. You find the coordinates. Then you just see with the help of the direction cosines, you multiply those. You will get cos alpha, cos beta, cos gamma. So this is the procedure of finding this one. So this is the important one. So they may ask for 10 marks or else you will get for the 5 marks question also. So only in this, this is only the concepts you have here. Tomorrow, not tomorrow, next Saturday, we'll start the second unit. Bisectors, it is there. So bisectors, it is the 10 marks question you will get. So you have any doubts in this unit?
No, ma'am.
No, ma'am.
No. So try to practice all the worked out exercises. Page number 28 and 29 you have. That is the foot of the perpendicular is there. This question you will get means almost in a 3D you have many example problems are there and exercise problems are there. Check your progress. So 3 different varieties are there. So compulsory any question means they may ask from the example problem or check your progress also. So solutions also given in the check your progress. Only the exercise you have to practice. So from anywhere they may ask the question. So if you know the concept of that one problem, and if you know the formulas, how to find them, so then easily you can solve the problems. So in first unit, only 10 marks question is this theorem, whatever it is there, and almost all are 5 marks questions only. So one you will get from that, and you have many all formulas, small formulas are also there. So they you will get for the objective type. So try to be perfect with the first unit. So you will get 2 or 3 multiple choice, but because here small formulas are there, finding the distance is there and finding the midpoint is there, and with the help of the ratio finding the coordinates is there. So you may have in multiple choice question or match the following, or even in the fill in the blanks also you will get. So two questions in multiple choice you may. So one match the following there means almost 4 questions, 4 objective type questions you may get from this one. Okay. So next we'll see the class. So try to practice all the problems.
Ma'am,
Yeah.
for this course, how many credits are there, ma'am?
For this one, you have the
3D
core no
geometry.
linear algebra.
Yes, ma'am.
Elective, you have only one, that is the 3-dimensional geometry you have.
Yes, ma'am.
Actually, before 5th semester, we used to have the 2 electives were there.
Yes, ma'am.
But all the books were not printed up till now. So only you have only one elective, that
3D
is the 3D.
geometry.
Okay.
So we'll be having same number of credits as that linear algebra, ma'am.
So linear algebra means for 5th sem mathematics, you have only 2. One credit is the course one.
Yes,
Okay, linear algebra.
And another
the second one is
3D
elective
geometry.
you have.
Yes, ma'am.
That is the 3D.
Yes, ma'am.
Okay. So even for your 6th semester also, you will have the same one. You have the numerical methods is there, and another one is the DMS is there.
Yes, ma'am.
So after your batch, they may add one more credit. That is, you have the linear programming is there. Actually, for 5th semester, 3D and linear programming, 2 electives were there.
Yes, ma'am.
But due to the pandemic situation, they were not printed the books. They were not ready for you. So only 2 you have now.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay.
Thank you, ma'am.
Thank you. Okay.